Okay, now this one, you don't have the denominator. Can you see that? Because when you're dealing with infinity, you go into the denominator. So you're going to have to create denominator by you see, you have to rationalize here. You don't have a choice. So it's a combination of the two methods here. Can you see now?
Yes.
Yeah, because with an infinity, you will say, oh, this is limits as this approaches infinity. So therefore, this is all over one, that story. So you'll be like, okay, let's go to the denominator. Like, I don't have denominator, it's basically one. It's the x is, the degree of x is 0 there. So rationalize to create that denominator. So in the parentheses, now I've got square root of x squared plus the 2x. And then the moment I move on outside the square root, the sign must change, negative x. Then I put it in the parentheses. Same thing must be there right at the bottom. All right, next step here will be limit. And then as x approaches, you know, I'm happy because I dealt with the one with square roots. This part you'll get it because what's coming, the derivative, it's very easy. Derivative of even sine, cosine rule, whatever. They're not bad. They're easiest. All right, we square the first term. So we have x squared plus the 2x minus the other one squared, x squared. There we go. Well, we can just deal with it. You can say you're left with the 2x. Can you see right at the top?
Yes.
All right, so let's just remove all this mess and just write 2x. Because we know the mathematics of addition. And then all over is going to be that story there. But we're going to have now to start pulling out the x squared and from the radical side. All right, so let's do that. So I'm going to have limit as x approaches negative infinity. All right, at the top, we've got 2x. And then all over. I'm pulling out the x squared, but the sign, when I do the absolute value, is going to be negative. So I'm going to write it as negative x. But you see, did you notice there is another term here?
Yes.
Minus x. So okay, let me show you what I'm doing. There will be like a minus x there once we pull it out, that minus x. Mm-hmm. So when I pull it out as a common factor, that means here must be a plus. That is if I pull it out. But I'm not going to pull it out as a common factor. I'm only doing by the square root. So meaning I've got negative x, then the square root of. So it's going to be x, under the square root, I must divide by x squared. So it's going to be 1 plus 2 all over the x. This is what's under the square root. And then that term, it's standing on its own, the one with an x. I don't have to pull out common factor. There we go. Then the next part, it's going to be, let's go pink. Because you guys, you like pink. So I'm going to go pink. So limit as x approaches negative infinity. So I'm already dividing by x now. I'm doing it. Last time I would show it with the red pen and cancel later. I'm doing it and I'm canceling. The top one will be 2x divided by x. It's just going to be 2 right at the top. All right, this is your stuff there. And then the bottom, the x is dividing here. So I'm left with the minus the square root of 1 plus 2 all over the x. And it's going to divide here, so I'm going to be left with the minus 1. Are we good?
Yes.
So what we know is that this part here becomes 0 there, where I put 0 in white. So I'm going to just keep it there as a note. Then we give them the answer. Numerator is 2. Denominator would be the negative square root of 1 is going to be negative 1. Then there's still another negative 1 coming through, then minus the 1. So my answer is 2 divided by negative 2, which is a negative 1. Is it making sense?
Yes. Yes, I got it.
Now, do you see this one was a trick one because it didn't have the denominator. You had to create it. Yeah, you had to bring back the denominator by rationalization. Yeah, all right.